Hello again, this is Colin Goebel. In this program, I'll try to show you how to use the standard C string library in C++ to manipulate old-style C strings. The library itself is right here. You can look it up on c++.com. It used to be called string.h. In the new ANSI standard, you pound include C string, which I'll show you in the program. And here are some of the functions that we're going to use. We're going to be comparing two strings, and we're going to be copying some strings. There's many other things in the standard library, as you can see, but copying strings and comparing strings is what this application is going to focus on doing. Okay, so in this demonstration of old-style strings, I referenced the standard C string library. That's the URL, and you can look up all of the various other functions that are available there. And I've included C string. It used to be called string.h. In the new ANSI standard, the pound include is to C string. As in my previous program, the first array is called string1. It contains the characters hello world, and as before, C++ automatically adds a null terminating 0 byte at the end. So the length of the string1 array is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters for hello world, including the exclamation point, plus 1. It's a 13-byte array. This program then outputs that array using the standard stream insertion operator, less than, less than. Now I'm going to copy that array into string2. And again, I want to note that you have to declare enough space in string2 to hold the largest possible string that you might want to copy there. This is particularly important if you're reading input from the keyboard in your program. You really don't necessarily know how many characters the user is going to type, and therefore how long your array should be to hold the user's input. In this case, of course, we know that the string is hello world, but the example I raise here is if you're reading input from the keyboard and you're asking for a file name, for example, you don't know how long the file is going to be or how long the file name is going to be. So it's really important that you allocate enough space here to hold the longest possible file name so that you don't get a buffer overrun if the user enters too many characters. I know it seems strange and I know it seems painful, but that's the way C strings used to work and still do. Okay, so the next thing that we want to do in this demonstration is copy string1 into string2. And I now want to notice that this assignment statement, string2 equals string1, just simply does not work for old-style C strings. The reason it doesn't work is a little bit technical, and I won't get into it here. But I will say that on my Bloodshed compiler, if I uncomment that line and try and compile it, the compiler will throw an error. At any rate, whether your compiler throws an error or not, it doesn't do what you might expect. What it does, in fact, if it were to work at all, would be to make string2 an alias for string1. It wouldn't actually copy the strings. As I said, the reason for that is a little arcane, and I don't want to get into it in this demonstration, but please bear that gotcha in mind. New style strings, the assignment operator works just fine, but if you're working with old style strings as arrays of characters, the assignment operator doesn't work. Instead, we have to use the strn function, which I've used here. It takes 3 parameters. The third is the maximum number of bytes to copy. In this case, I've specified 100 because my destination array has only 100 bytes in it. If I were to copy more than 100 bytes, I would have a buffer overrun bug in my program. So since I've only reserved 100 bytes for the destination string, it's really important that I don't insert more than 100 bytes into that array. And that's what strncpy does. So string1 is copied into string2 with the caveat that no more than 100 bytes are copied. In this case, we know string1 has 12 bytes in it, I think, with an additional null terminating byte. And of course, the copy ends at the null terminating byte because there's no point in copying more characters than are actually in the string. But let me say again, it's really important that we tell strncpy to never copy more than 100 characters because that's the size of the target, the destination array. Now, as with the assignment operator, we cannot use equals equals or not equals to test if two strings are the same. When we run this program, you'll see that string 1 is declared as being different from string 2 using the equals equals operator. Again, the reason for this is a little arcane. It works differently from strings in C++. And so all I can say at this point is just remember that if you want to compare two strings, don't use equals equals or not equals. You should use the strcmp method. This takes two parameters, string 1 and string 2, and it returns a value of 0 if string 1 and string 2 are equal. Let's run this program and see how it works. We'll compile it and run it. We'll see that there's the original string, string 1. There's string 2. It's been copied. Hello world has been copied into string 2. Just notice that using the equals equals comparison operator, C++ tells us that the strings are different. But using strcmp, C++ tells us that the strings are the same. So be very careful when you're using old style C strings to use the functions of the standard C library. To refresh your memory, it's right here. It's called string.h or C string, and the functions that you'll want to use are enumerated in this library. They compare strings, search strings, append one string to another, and so on. And I'll let you look up the details at your convenience. But always remember, using old style strings, to use this the standard C library in the C string library. It's now called C string, and previously it was called string.h. Thank you.